Michio Kaku's extraordinary intelligence has led to an amazing discovery. The James Webb Space Telescope has detected a mysterious signal coming from the Andromeda Galaxy. For more than a century, the interpretation of Andromeda was simply a terrestrial planet, but thanks to the James Webb Space Telescope, our view is completely different. These new data sent shock waves through the scientific community. But what does this surprising revelation tell us? And why does it cause confusion among scientists? Join us as we dive into the details of this discovery and explore how understanding will impact the world. Before we talk about the alarm signal, it is important to understand some facts about the Andromeda Galaxy. Andromeda is the first sign that our planet is outside the Milky Way. This discovery expanded our understanding and showed that we can also be a small part of the big world. At first, the Milky Way was thought to be the entire universe. Early astronomers with limited technology could not distinguish the individual stars of the Milky Way. This changed Galileo Galilei in the 17th century. Using a telescope, Galileo discovered many stars in the Milky Way, challenging the idea that the Milky Way was the only galaxy. The real breakthrough came with Edwin Hubble in the 1920s. Using the Hubble Space Telescope, Hubble observed distant objects outside the Milky Way and identified them as special galaxies. Expands our worldview. One of these galaxies is Andromeda, also known as M31. The sighting dates back to the 10th century, when the Iranian astrologer Abd al-Rahman al-Sufi predicted it without the aid of modern technology. In the 20th century, advances in technology allowed astronomers to explore further, and Andromeda was discovered to be a large galaxy, similar to our own Milky Way, but 2.5 million light-years away. Observations of Andromeda have evolved significantly, from ground-based telescopes to space-based observatories such as Hubble and now the James Webb Space Telescope. Each new device brings us closer to understanding Andromeda's true nature. As astronomers delve deeper into the universe, Andromeda becomes a symbol of our Milky Way, showing its formation, evolution, and growth. The connection between the two galaxies is crucial to understanding the future of the Milky Way, especially since it will collide in about 4 billion years. Recently, the James Webb Telescope detected an eerie signal from the Andromeda Galaxy. The telescope's sensitive instruments detected unusual activity in Andromeda, indicating a significant change from previous observations. The key finding is the change in Andromeda's mass estimate. Although Andromeda was thought to be larger than the Milky Way, new information suggests that the difference may not be as large as previously thought. Updated measurements show that Andromeda and the Milky Way are about the same size, changing our understanding of the universe. In addition, the James Webb Telescope has provided clear images and features of Andromeda that reveal new star formation and chemical compositions in the galaxy. These data are important to understand the evolution of galaxies and the conditions that lead to the formation of life. Another important discovery concerns Andromeda's strong core. The data show that the black hole at the center is more powerful than previously thought. This process affects the surrounding regions and affects the shape and future of the galaxy. Insights from this spying reveal the mystery of the dark. By studying the effects of the halo on Andromeda's stars, scientists can better understand how dark matter is distributed throughout the universe. These new discoveries from James Webb's television have sparked a lot of research. Scientists around the world are sifting through the data to uncover more of Andromeda's secrets. Each discovery contributes to a better understanding of how the universe works. Andromeda, our closest galactic companion, has many unique features that fascinate astronomers and set it apart from other galaxies. First, Andromeda is huge. More recent data show that it is 220,000 light-years across, making it one of the largest galaxies in the local group, larger than the Milky Way. Its sheer size contributes to its mass, which is estimated to contain 1 billion stars. More than our galaxy, Andromeda's character is another popular character. It's just a spiral shape, but it's stretchy. The galaxy has a prominent core surrounded by rings of dust and gas, a region of active star formation. These features characterize the galaxy's dynamics and the processes that shape its shape and evolution. Andromeda's core is interesting because it is a double-layer wave representing a supermassive black hole. In addition, Andromeda is surrounded by a copy of stars, planetary nebulae, and planetary clusters thousands of light-years away. This provides clues about the formation and history of the galaxy. Especially circular clusters are very beneficial. With more than 460 studies so far, they provide insight into the early formation of galaxies and the dynamics of star clusters. Another notable feature of Andromeda is its constellations. There are more than 20 small galaxies orbiting Andromeda, some of which are missing stars and gas, which helps Andromeda grow. This process, known as galactic cannibalism, shows the aggressive nature of galaxy formation and provides real-time information on how galaxies grow and interact over time. The future and development of Andromeda is a big question in astronomy. One important feature is its transformation from a spiral galaxy to a ring galaxy. According to the findings, changes in the structure of the galaxy lead to this unusual shape. Ring galaxies are rare and often form under special circumstances, often after a collision or close encounter with another galaxy. If Andromeda evolved into such a structure, it would point to a history of interactions with other galaxies. That Andromeda's fate is closely linked to its merger with the Milky Way, and it is estimated that the two galaxies will collide within 4 billion years. Although this event may seem negative, it is a normal part of the evolution of the world. This collision does not involve a direct interstellar collision due to the great distance between the stars. However, the energies of the two galaxies are also changing, and the gas and dust in each part are mixing, forming new stars. This burst of starlight illuminates the merging galaxies, creating a unique and spectacular astronomical event. Changes in the Earth's cycle affect weather patterns. Some species will survive under these new conditions, while others will become extinct. In addition, this merger can create new stars due to the collision and compression of gas clouds from the two galaxies. If this star forms close to our solar system, the radiation from these new stars will have a significant impact on Earth's climate and environment. However, it is important to remember that these events will take place billions of years in the future, when humanity will have advanced significantly or our species will have settled in different parts of the galaxy. The observations of the Andromeda Galaxy have a profound impact on our understanding of the universe and its future. Comparing Andromeda to the Milky Way will help astronomers better understand the formation and evolution of spiral galaxies. Observing Andromeda's features, such as its spiral arms and supermassive black hole, is a clue to understanding similar features in the Milky Way. This simulation approach refines our models of galaxy formation and evolution. In addition, measuring the size and mass of Andromeda will challenge previous assumptions and change our understanding of the Milky Way's place in the local group of galaxies. Galaxy and its influences. Although the Milky Way is currently a prominent galaxy, interactions with nearby galaxies such as Andromeda could change its shape. Understanding Andromeda's evolution provides clues about the processes that cause major changes in the galaxy's shape. By studying Andromeda's current shape and predicting its future orbit, astronomers can model the effects of the Milky Way, including changes in star formation, gas distribution, and the stimulation of the galaxy. The world has made great progress through technology. From the first telescopes to today's observatories, each advance has expanded our understanding of space. The journey began with the invention of the telescope in the mid-17th century, a simple device with lenses in a tube that allowed astronomers to observe the moons of Jupiter and the phases of Venus. Over time, telescopes became more sophisticated and powerful. In the 19th and early 20th centuries, larger and more advanced telescopes were built, allowing astronomers to peer deeper into space and see celestial bodies. Including Neptune. However, ground-based telescopes suffer from atmospheric interference and light pollution. The launch of the Hubble Space Telescope in 1990 was a major breakthrough. By being above the Earth's atmosphere, Hubble provided clearer and more detailed views of the universe than ever before. The discoveries made major advances in our understanding of dark matter, the age of the universe, and the evolution of the universe. Since Hubble has a variety of space telescopes, including the Chandra X-ray Observatory and the Spitzer Space Telescope, it has probed the universe at different wavelengths and expanded our space tools. These instruments allow astronomers to detect and study features such as the universe's microwave radiation, star-forming regions, and remnants of supernova explosions. Darkness is one of the world's greatest mysteries. Unseen but visible, the dark does not give, shrink, or reflect light, making it invisible to tradition. Its presence is determined from the effects of energy on the visible and macrostructure of the universe. In Andromeda, evidence of dark matter comes from the galaxy's rotation speed. Stars near the edge of the galaxy rotate at the same rate as stars near the center, which is the opposite of what would be expected if things were just observations. This uniform rotation is an important indicator of the hidden mass attributed to the dark matter that surrounds and influences the galaxy.